Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Count vowel strings in ranges, Leetcode 2559. In this problem, we are given 0 index array of strings, words, and a 2D array of integers, queries. Now for each query with the specified range li, ri, both inclusive, we have to count number of words in a specified range that start and end with a vowel. And in the end, we have to return an array answer of size queries.length, where answer I is the answer to the ith query. Note that the vowel letters are A, E, I, O and U. Then in example 1, for the given words, the first query is 0, 2. So we will check the words at index 0, 1 and 2. And we have to count how many of these words start and end with a vowel. So word ABA starts and ends with the vowel A. Then word BCB doesn't start with the vowel. And word EC start and end with the vowel E. So total number of vowel bounded words in this range are 2. Then for query 1, 4, we will check the words in the range 1, 4. So we can see that word BCB doesn't start with the vowel. And word ECE, AA and E, all of them start and end with a vowel. So the count for this query will be 3. And finally for the last query, the range of the index is from 1 to 1. So we have to check word BCB and it doesn't start and end with a vowel. So the count for this query will be 0. And as we are done with all the queries, now 230 will be our answer. Now in terms of solution, one of the naive approach can be to iterate through each query. And for each query, we traverse to the specified range of words array and count how many words start and end with a vowel. This approach involves nested loops, leading to the time complexity of O of q into n, where q is number of queries and n is number of words, which is not very efficient. And the bottleneck of the naive approach is that for each query, it takes O of n time to count number of vowel bounded words. So can we preprocess the array to reduce the query time from O of n to something lower? And the answer is yes. If you remember, we have seen similar problem in the past as well, such as XOR queries of a subarray. In that problem, we needed to repeatedly XOR elements based on the indices provided in the queries, and there we use prefix-sum technique to optimize the solution. And given the nature of our current problem, the prefix-sum technique can be useful here as well. We have to preprocess the words array to create a prefix-sum array. So we denote a word as 1 if it starts and ends with a vowel. Otherwise, we will denote it with 0. For example, for this words array, the output will become 1, 0, 1, 1, 1. So now we have it in the numbers form, so we can actually generate the prefix-sum array from it. The prefix-sum array will store cumulative counts of vowel bounded words up to each index. So for the 0th index, we will take the element as is. Then at index 1, value is 0. So prefix-sum will be sum of prefix-sum at the previous index plus current value, which is 1 plus 0. So it says 1. Then at index 2, value is 1 and the previous prefix count was 1. So 1 plus 1 will become 2. Then at index 3, value is 1 and previous prefix sum was 2. So 2 plus 1 becomes 3. And finally at index 4, the value is 1 and previous prefix count was 3. So it becomes 3 plus 1 equal to 4. But we still need to handle one extra case. And that is the case when we have an empty range. That is, we have not selected any element. So for that, we will start the prefix sum with value 0 here. And now that we have filled in the prefix sum array, let's try to visualize what the indices in the prefix sum represent. So this is our prefix sum. And if we are at point L, then prefix sum at index L will represent the number of vowel bounded words in the range 0 to L minus 1 inclusive. And prefix sum at index R plus 1 denotes the number of vowel bounded words in the range 0 to R inclusive. And for the given query L, R, we want to count the vowel bounded words in the range L, R inclusive. And we can see that it is the difference between prefix sum at R plus 1 and prefix sum at index L. So our answer for this query will be prefix sum of R plus 1 minus prefix sum of L. For example, the indices of our prefix sums will be 0, 1, 2, 3, 4 and 5. And first query we see is 0, 2. So our answer will be prefix sum at index 3 minus prefix sum at 0, which will be equal to 2 minus 0 equal to 2. Then the next query we see is 1, 4. So our answer will be prefix-sum at index 5 minus prefix-sum at index 1, which is equal to 4 minus 1 equal to 3. And finally, for the last query 1, 1, our answer will be prefix-sum at index 2 minus prefix-sum at index 1, which is equal to 1 minus 1 equal to 0. And now we are done with all the queries, so we will return 230 as our answer. And by using the prefix-sum, we reduce the query time from O of n to O of 1 for each query. So our overall time complexity now becomes O of n plus q, where n is number of words and q is number of queries, because first we are calculating the prefix-sum for n words in the array, which takes O of n time. And then for processing the q queries, it takes O of q time, as each query can be answered in O of 1 time. So overall time complexity is O of n plus q. And in terms of space complexity, the auxiliary space we require is O of n for storing this prefix-sum. And we will anyways need the O of q space for storing and returning the answer. Now let's jump into the code part. First, let's create set of vowels for efficient checking of vowels later. Let's also get number of words in the input array and create a prefix-sum array with one extra element to store the cumulative count of vowel bounded strings. Now let's iterate on the words array and initialize the current prefix-sum to the previous prefix-sum. Let's also get the current word, and now we have to update our prefix-sum. So if the word is a vowel bounded word, then we will increment the prefix-sum by 1, otherwise the prefix-sum stays as is. And when I was explaining the solution, I was using a binary array, but we don't have to use it here, since we can directly check if the first and last character in the string is a vowel. Then we will increment the prefix-sum by 1, otherwise the prefix-sum stays as is. So let's do it. If the first and last characters of the word are vowels, then we will increment the prefix-sum. And now that we are done with the prefix-sum calculation, let's initialize the answer array to store the results of the queries, and iterate through the query array and get the range, that is left and right indices of the current query. And our answer for this query will be prefix-sum of r plus 1 minus prefix-sum of l. And once we are done with all the queries, we will return our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.